Okay, it's Friday again. Let's see if I set everything up correctly. And while we're waiting for anyone to join the show, seems to be fine. Okay. Actually, I see. Okay, seems to be better right now. Okay, let's wait for 1 minute and let's get started. Uh, okay, hello everyone. It's Friday again, and happy to see you on in TGIP episode 7. And in this episode, I'm going to sharing a bit experience and also the knowledge about the geo-replication. And in order to fully leverage the power that provided by Pulsar in geo-replication, you really need to understanding the concept of cluster because only you can understand the concept of cluster, you know how to configure geo-replication correctly. Like either you also know how to configure geo-replication without a global zookeeper. And it will also provide a lot of flexibility that you can do stand, stand, active standby, aggregation, full mesh, and that all tied to understanding the concept of cluster. So I kind of putting up the cluster and geolocation together as one of the topics. So as usual, let's get started with reviewing what's happening within Pulsar community, and I'm going to share my show notes into live chat. If you're interested in check out the content, you can also click the link in live chat. And yeah. So, what happened in the community this week? I think one of the most biggest news is we finally approved the 2.5.1 release, and it includes close to 158 pull requests, and it sounds like it's a bug fix on 2.50, but actually including a lot of bug fixes and enhancements. So please take a look at check out the release note, which includes all the features and bug fixes, and as well as enhancements that include in 2.5.1. It's a very excited milestone to the whole community, and thanks everyone for contributing to this major release. And Guangning, who is the release manager for Pulsar 2.5.1, also wrote a blog post about Apache Pulsar 2.5.1. He walked through all the kind of the major changes that happened in 2.5.1, including features, enhancements, and critical bug fixes. Feel free to check out the blog post and really understand uh, what uh, what does this feature mean to you and fully leverage the power of Pulsar. And Things 2.5.1 includes a lot of great features and enhancements. I think it was a kind of a separate episode to discuss all the features included in 251, and how I would do another walk through 251 in details in the episode next week, and that is 251. Uh, we still there's a webinar upcoming in next week that is from David from Overstock, and he's going to talk about common architectural patterns on Pulsar. Namely, mainly he would focus on two topics. Is one is high performance streaming enrichment with Ignite, and master-based distributed tracing with Flink and Jaeger. And he will also talk a lot of best practice that he has in production. So if you have any questions, want to hang out with Stefan, please sign up. This webinar is coming on the next Tuesday, so don't miss it. And okay, so go back to the main topic that we want to share this week is about geo-replication. But the whole concept about geo-replication is really tied into cluster. And what does it mean? And I know Pulsar, we already kind of provide a very good documentation for you to looking into about geo-replication. So if you search geo-replication, you are able to find you have a lot of links talking about how geo-replication work and how do you config geo-replication and also enable geo-replication namespaces. So a lot of materials in Postal website, but in my kind of show, mostly I want to give you more a deep dive into kind of how does this thing work. Especially, I will just use some kind of demos to showcase like how exactly it works. And in this show, I think the first thing, the main focus would be help you understand what does cluster mean and how is the cluster information is stored in ZooKeeper and what is the ZooKeeper structure. And there are kind of two parts. That is, by default, you need a global ZooKeeper to configure geo-replication uh, between clusters. And that is what already provided in the open source documentation. But sometimes you probably don't want to manage a global zookeeper. You can still do geo-replication without a global zookeeper. For example, if you only have two clusters, I just want to set up a cluster-to-cluster replication. You don't really need a global zookeeper in order to do geo-replication. And I actually write a kind of a demo uh, probably a couple years ago. I mean, I don't remember where it was created, and but I think there's some of the people already kind of try it out, and also make it work with TLS replication. So that is also a great source. You want to check it out. But in my show, I would basically walk you through to help you understanding the concept of cluster and how geo-replication work with global zookeeper and without a global zookeeper. So I actually have a few slides that I use to kind of give a presentation to customers that to help them understand a bit how geo-replication works. And I would use those slides to walk you through some of the basic concept before we dive into a few demos to understanding how these mechanisms work. So I think cluster is probably the most important concept you need to really understand before you deep dive into any geo-replication settings. Uh, so in Pulsar, a cluster is identified by a cluster name, and the cluster name is mainly used for configuring geo-replication. And each cluster has a cluster configuration. And within the cluster configuration, you would have four service URL that it provides a kind of different entry point for you, for your application to access the cluster. And usually when you set up a cluster, you would know this very famous initialize cluster metadata command. Basically, it asks you to provide four web service URL or service URL for you to identify this cluster. But during the initialization, the list four service URL are mainly used for creating a class configuration for the cluster you specify. And this service URL you can change in any time by through using a cluster command that provided in the parser admin command. So you can create cluster, you can get cluster, update cluster, and list available cluster. I walk you through some of the commands later, but that is the operation that you can do later to register new cluster and kind of connect the cluster together to form a geo-replicate instance. So this is a very simple diagram to show the built-in features that provide by Pulsar, which is the full mesh geo-replication. Full mesh means if you have multiple clusters, it can configure to replicate between each of the cluster. And the main kind of knowledge that sorry, within the geo-replication, the most challenging problem is how each cluster can know from each other. But basically, from cluster one, how can I know class two and class three? And the idea in Pulsar is you bring in a global zookeeper. The global zookeeper is a configuration storage that will be used by all the three clusters. And you basically put the cluster information and configuration in the global zookeeper. So all the cluster would know where to find each other. And if you want to add a new cluster, you just add a new cluster, add a kind of new metadata within this global zookeeper, and all the other cluster would know about the newly added cluster. So the purpose of the global zookeeper is mainly for storing all the configurations about clusters and also about the replication settings. I can walk you through some of the information that's stored in Global Zookeeper. And so two commands you will really need when you configure a geo-replicate cluster is the first thing you need to create a tenant and specify a list of cluster that is allowed for placing this tenant in these clusters. You are able to do create namespace, also create topics and allow topics to produce and consume the messages within this cluster. So this is called allowed cluster, but it doesn't mean the all the namespace with these tenants will be replicated across this across all the clusters that are provided in this list. And another command is you need to create a namespace, and the namespace will specify a list of cluster. The list of cluster you specify in the namespace creation should be a subset of this allowed cluster. Otherwise, you are not able to create a namespace that is replicating the topics between clusters that are allowed by this tenant to a cluster that is not in the allowed list of this tenant. So the so that means that basically the replicate clusters of a given namespace should be a subset of the allowed cluster of a tenant. So that is the very important thing you need to keep in mind. And how does it work? So it basically the workflow is very simple. Is once you configure a namespace to be replicated between two clusters, each the broker in each cluster. In this example, I'm using a slice from Java before. He basically demonstrated that I have a cluster in Beijing and another cluster in Shanghai, and you configure the replication between these two clusters. So when you configure the geo-replication, uh, the broker would create a replication cursor. And the replication cursor, what it does is basically tracking the messages is being replicated from one cluster to the other cluster. In this example is you have, sorry, you have a Beijing cluster, and the broker in Beijing cluster will basically create a replication cursor. It will read the entries out of topic in that start in Beijing cluster and create a producer that is producing the messages to the remote cluster. And the same thing would happen in the remote cluster. It would also creating a cursor to read the topics within its local data center and create another producer to replicate the data back. So all it does is basically just open a cursor and open a producer replicate. And once the master has been replicated to the remote data center, it will acknowledge and moving the cursor. So using the cursor approach, it ensures there's no data, so you will not lose any data during the replication because all the replication state is tracked by this cursor. And when using a producer to produce a replicate mastery from one cluster to the other cluster, you can enable broker-side deduplication. So this would ensure the replication happen in an exactly once way. So this will just give you a rough idea about how geo-replication work. And I would have a demo later, so I'll skip this slide. But basically, uh, if you have, so by default, if you configure a geo-replication with a global zookeeper, that means all the cluster will connect to a global zookeeper. It will know exactly what the cluster will looks like. And that is kind of the default settings, the recommended settings that Pulsar provide in its documentation. And I would use one example to showcase how exactly geolocation work in with global zookeeper. So I actually have let's say let's see. I use Kubernetes a lot, so I use in this demo I just use Kubernetes Helm chart to deploy three clusters, and each of the cluster would sorry, I'll deploy a global zookeeper. Deploy a zookeeper cluster that simulate as a global zookeeper, and I'll deploy three different set of cluster that is used for simulating three different clusters. And so as you can see here, we just use same Helm chart because the Helm chart was developed in a way that you can deploy individual components, or you can deploy a whole set of the cluster. So that's the technical. So I have four value files. One is for deploying the global zookeeper as the global configuration store, and three clusters that represent a cluster running in East Coast, West Coast, in Central. So let's just take a look at a bit uh, the values file. So in the global case, I basically just disable all the components. If you see here, I basically disable all the components. I also disable the monitoring components. I only keep Zookeeper available here. And I would, let's take a look at the Easter cluster. It's very similar. But I enable all the components, so I would have local zookeeper for East Coast cluster, and all the necessary components. For demonstration, I deploy some of the unnecessary components like Presto, KOP, and proxy and functions, and a bunch of the marketing components I also disable. The only difference here is, as you can see here, we actually have a configuration called configuration star that is configured to be pointing to a kind of a global zookeeper that was set up by the mm, by this value file. So you would have a cluster that is setting up by only running a zookeeper cluster. And I call it demo full mesh global because it's a full mesh replication demo. Similarly, I kind of duplicate the settings for create a West Coast cluster and also point to a global zookeeper. And the central one also point to the global zookeeper. So as you can see here, I have four cluster ready. They call the global zookeeper is demo full flash, global demo full mesh, east, west, and central. And just to show you a quick idea is, so I have the okay, I think I got into a different namespace. Let me switch to the namespace. Okay. So as you can see here, I have this global zookeeper running. I only set up one pod for zookeeper as for demonstration, and I have the a cluster that is running for central, and I have another cluster that is running for east, and another one running for west. Okay. So if you go to the Zookeeper, that I can show you a bit what kind of information that you actually store in the global Zookeeper. So Pulsar actually provide a tool that called Zookeeper Shell that you can run. It actually connect to the local Zookeeper, so which is the global configuration store. So let's see. So as you can see here, it actually store admin information. What is the admin information here? So it's used for storing all the cluster information. Since I have three clusters, so it's actually the central, east, and west. And so for each of these cluster, you actually it will store all the service URL, the service URL used for connect to this cluster. So in this example, since I run in the same Kubernetes cluster for demonstration, so it store the kind of um, the broker service URL for be able to access the cluster. So if you check individual ones, you should get the similar configuration settings. Let's see. So you can see this is the central, this is the east. You should get the same thing for the west, and that means if you want to set up a geo replication, whatever service URL you provide here should be accessible by the remote cluster. Otherwise, you are not able to establish any connections between the cluster, so you are not able to do any geo-replication. So that is the first thing. So you need a cluster information. This cluster information is used by configuring geo-replications. And some other additional information that you can get here is, for example, like you're able to see a lot of these policy, and the policies put in the global configuration store is those policy would actually including some of the geo-replication configurations. So for example, we usually have a tenant called public. So actually, this is the, let's see, so should be able to get the tenant information. So as you can see here, this tenant, this information is basically tell you you are able to get the sorry, this tenant is allowed in these three clusters, like the west, the central, and the east. And if you want to check a bit more, let's take a look at let's check the default one. So this is the default namespace. And the default namespace is configured to replicate between these three clusters. So it's a full mesh replication. So you will see the replication cluster here is the west and the east, and as well as the central. So to help you understand a bit kind of the how this information is changed is that actually let's go into the cluster. So I actually opening up three terminals just to kind of demonstrate. So this is for the kind of a terminal in east cluster. This is a west cluster. This is a central. Okay, so let's do one thing. Let's create a namespace. Uh, let's run any command here is let's just take a look at namespace dist so not StreamNative public. So as you can see here, you actually get the same kind of command here. I can actually run on each cluster. So you'll be able to see the exactly same thing because all these namespace are tenant in namespace are global. So you're able to see individual namespaces. Okay, so once you have this, let's walk through an example. Let's create namespaces. Namespaces create public. Let's call it TGIP. Okay, so let's just take a look at what when you create a namespace, what does it mean? Let's see. Namespace is get clusters. It will return the replicate clusters. So as you can see here, it actually create a namespace that is local to this cluster. So even the public tenant is configured globally to be available to be allowed across three clusters. But when you create a namespace, it's actually create a namespace that is only replicate, non-replicate, just placed in this local cluster. So that is the default behavior. So if you go to the BookKeeper, you should be able to see exactly the metadata you store in the namespace policy. So you see replication cluster that is coming from the east. You only have east. And let's just do a quick demo. So this namespace is visible to all the three clusters, but it's only set to be able to replicate in this east cluster. So if I run this, let's say, the namespace, I should be able to see exactly the same namespaces. So I see TGIP here. So if I go to the west, sorry, you should be able to see exactly the same output as what you can see in the in central. So you can see TGIP here. So let's try to produce from east, no west coast. Uh, think of let's just use produce. Uh, this is an attempt to produce a messenger from west coast, west. And let's just give a random name because it failed. So I'll just call it a failed attempt. A fail. I believe it will fail. So as you can see here, you will see namespace is missing local cluster name in the cluster list. That is because this cluster is only configured to replicate in um, each cluster. So if you are trying to produce to such namespace, you are not able to produce because it doesn't make any sense. This namespace is only configured to like available in east. So how will I have three cluster, how I want to configure a geo-replicate cluster, geo-replicate namespace. So what you can do here is let's command and the namespace command called set cluster. So you're basically providing a cluster list. Uh, I need to figure out what exactly cluster name. Yeah, so I can use, oh, okay. I can use the password admin cluster list to find the available cluster in this global geo-replica instance. So you have three clusters. And let's see. I want to just let me just configure to be a fully replicate cluster in between all these three clusters. So you specify all the clusters, and then you specify the namespace. Then you will be, yeah, here we set the cluster to be fully replicated between three namespaces. let's take a look at the name, the kind of the, no, okay, I didn't run a command. Okay. Uh, oh, yeah, I didn't run a command in here, but I can run it again. So if you take a look at TGIP, you should be able to, oh, sorry, now get classes. You should able to see right now it's configured to replicate between three clusters. And if you go to check the metadata, you will see the metadata is actually updated to the global zookeeper. So you will have these three um, classes. So let's take. So once you have that, we can just see how it works. So let's try to start three consumers. So there would be consume. Let me see. Consume given subscription call. I'm from East US East. Uh, just waiting infinity there, and specify a topic that's TGIP episode. What's the episode right now? 7. Okay. So you basically try to consume from East, and let's start a consumer in the. This is central in the central as well. Then I will start another one in west. So you have all these three regions. Uh, then let's try. Let's see where are we. Okay. I mean west. That's produce master. Produce dash m. Hello from west world. Yeah. And let's give the topic name. What's the topic name? There you go. So as you can see here, I produce a master. All three classes receive that master. That means once you configure the settings, all these three brokers would get the namespace policy updated. And I know, okay, for this namespace, I need to set up the replication between classes. So when I produce from West, and the brokers receive the master in the West cluster, would replicate the master to east in central. So I can do a similar experiment in the, let's see, in east. Let's go to the east terminal. Let's just copy. Oh, I don't have that. Uh, produce hello from east. And let me copy the topic again. So 7. As you can see here, when you produce from east, all the three clusters will get a master. And that is the kind of the recommend way for setting up a geo-replicate clusters by Pulsar, or recommend in the Pulsar documentation. But actually, there's a lot of use cases that you probably don't have a lot of clusters that are spanning across the world. You only have two clusters. And most of the time, you want to set up an active standby model. So how do you want to how can you configure that? Because by default, if you're using a global zookeeper, you only get a full mesh replication out of the global zookeeper. Because the replication settings is actually actually global setting, so everyone will see exactly the same replication setting. So you're not able to configure standby active standby pattern. And in IoT use cases, you might running clusters in cloud, but you have a lot of small edge clusters. You want to replicate the data from edge cluster to your cloud. Then how you can configure aggregation pattern? You aggregate all data from individual small edge clusters to cloud. For sure, you are not able to do that through a global zookeeper. And in some sense, you probably don't want to configure your edge cluster to talk to a global zookeeper because it doesn't really make sense to talk to a global zookeeper. And how can you do that without a global zookeeper? And that is the most interesting thing in a lot of conversation I have with customers is they want to really understand how exactly the geo-replication work. So as you can see here, a lot of this geo-replication works just just fully rely on these settings called replication cluster. And replication cluster is actually using the cluster information that register in this cluster to figure out where I can connect to that cluster. So by playing around these settings, you are actually able to do very flexible patterns like aggregation pattern. I want to aggregate all the data to a remote cluster, like the IoT use cases, and I want to configure a failover pattern that I have an active cluster and a standby cluster. So all the trick here you can see is you need to let cluster one know how to access cluster four. Cluster four doesn't need to know the existence of cluster 1, 2, 3, but you need to that cluster 1 is able to connect to cluster 4. And similarly, for failover pattern, you kind of managing in a way, you know, okay, there's a active cluster and there's a standby cluster. And when you want to switch over, you want to change the replication settings. So, so kind of using failover pattern as a demo to see how you can achieve that. Because once you understand how to configure an active standby, you're able to do the same similar thing for doing an aggregation pattern, and that is the most powerful mechanism in Pulsar. So I actually have a separate demo. Let me see, where is it? Okay, it's called active standby. Let me see. Yes, it's an example. Uh, it's very simple. So you just create two clusters. One is called active, and the other is called standby. Those are two fully isolate cluster. Uh, uh, I just created in a different namespace, community namespace called Pulsar Active Standby for demonstration. And as you can see here, it's different from uh, the full mesh one. In the full mesh one, I actually config the cluster to point to a kind of global configuration store. But in this one, I basically just config a fully isolate cluster that it has its own configuration store and it's to keep a cluster. And the other one, I believe it's exactly the same. There's no other changes. So, uh, and I use the Helm install Helm chart using exactly the same chart. There's no difference, and I call it east and west. And I don't even call it active and standby. I just like name it east and west. And I create two panel here. Let's take a look at Kubernetes. Okay, this is the demo I used for full mesh. I think it's in two, no, one. Yeah. So I have two clusters running. Each cluster has its own zookeeper cluster. So it's a kind of a, you can think about it as a fully isolated to environment. And ideally, in most of the case, you would think about, this two cluster doesn't connect with a configuration star, how I can connect them together. So let's go take a look at how we can do that. Uh, I want to show the first thing. Let's take a look at Zookeeper. And it should be Zookeeper shell. Oh, what did I tap? No. Oh, I see. Another K. Okay, so let's look at that. So as you can see here, it has much more information that you get from the full mesh one. So in the full mesh one, the global configuration story, you actually get the admin dnode. Uh, that is because this cluster is a fully isolated cluster that it put all the namespace policy and configuration together with all other metadata information in the same zookeeper cluster. So they're kind of fully isolated. And if you want to check a bit more, so you can see here, they're also slightly different settings like a local policy and some other configuration stuff. But from cluster perspective, you only see, oh, I have East cluster. And let's take a look at, do the same thing for this is East. Let's do the West one. Let's go to a terminal. Oh, no, sorry. I need to go to the zookeeper one. So if you go to this zookeeper shell, you will see the same thing. And if you see the cluster, you you see exactly different cluster. So each cluster right now is fully isolated. You cannot see each other. You only see yourself. And how we want to make this connect to each other. So then let me open a new terminal. Let me split that panel. Let's choose East as active. And we want to choose the West as standby. So the first thing you want to making sure you're able to replicate the messages from east to west. So basically, you need to know how east cluster can connect to west cluster. So the first thing you need to do here is let's take a look at also at the mean clusters list, and I need to get a configuration here. Yeah. So as you can see here, this is kind of the service URL that you can use for connecting to the west cluster. So I want to config east to be able to connect to west. What I need to do first is I need to register a cluster in east. So I need to go, so right now in the east, I only know there's a cluster, which is east. Then I need to create a cluster. Let's see, I don't remember the command. I need to specify the service URL. So I would use the service URL here. And I need a broker service URL in order to produce the messages. Oh, I need to give a cluster name. That's my bad. Okay, this cluster name is, okay, it's the West cluster. Double check. So I register a cluster in the East cluster. So no, I need to list the cluster. You can see right now I know East cluster, I know West cluster. So if you take a look at West, it should still be, it only know West. So this is because this is kind of to isolate environment. Um, Now what you're going to do next is I know two cluster already, and I want to leverage the cluster for the replication. So I need to do is making sure I add this cluster uh, to the tenants, to the allowed list in the tenant, so the tenant can use that cluster. So let's take a look at tenants get public, still using public as the tenants. As you can see here, it only allow uh, to be in the East cluster. So you need to first set the, I think it's set, not cluster. Okay, you need to set uh, dash dash allowed clusters, and you need to get put the east and west into the allowed list and specify the, where is it, public. Hmm, no list. I think it's called update. That's the update. Okay, so we get it set up. So let's double check. Let's update it. So this is get public. So as you can see, it's allowed in these two clusters. If you double check in the west side, I think you should be able, you should only see one cluster, that is the west. Okay, so you have, so east know west, but not west doesn't know east. So I want to uh, get tenant set no, I need to create a namespace now. Namespace is created. I need to know the command dash dash clusters. Since I want to replicate to west, so I just put east and west together in the cluster, and that's still called the name TGIP. Okay, so as you can see here, I have a namespace, but if this is kind of a a different cluster. So when you go to the west cluster, you can list the public tenant. So there's no TGIP namespace because those are kind of two isolated one. And this is the namespaces created. Sorry, I need to get. I think get clusters TGIP. So you should be able to see. Okay, this is the two clusters. And in order to make the replication happening, you need to create a similar clusters, but since you don't want the data replicate from west to east, so you just create a local um, namespace in the west cluster. So if you check this again, yeah, so you can see that there's only one there. And how to kind of demonstrate that this actually working is uh, the same thing is I need to split my terminal. Let me still do create a subscription consume dash s sub. So this is sub. This is from active dash and wait for forever and create TGIP episode 001. So as you see here, I'm listening in this topic, and this is standby, and I want to verify that message can actually be sent from west to east. So as you can see here, I want to create a standby subscription in the west. So as you can see here, it's also waiting. So let's open another terminal, try to produce from east. So produce dash m hello from east. Uh, it's a topic episode 11. As you can see here, we are in two isolate cluster, but I configured geo-replication from east to west. And it actually, the consumers, you're able to see the replication from one way to the other way. And if we want to really double check that the west cannot replicate to the east, I can do the similar thing here. I can go to west part, and I can do the similar command, produce dash n hello. This is a master that should be received by the consumers in the West, and specify the topic. As you can see here, only the consumers in the West receive the messages, and the consumer in the East doesn't receive any message. You can think about, you can say, oh, there might be a trick or bug. Let me just produce another message. Hello again from East to double confirm. That is not a trick. So you can see here the East, any message produced in East that you can receive in East, and as well as in West. And any message produced in the West, only the West producer is able to receive it. So this is the way how you can, as you can see here, the magic here is you really need to understand how the cluster concept works in Pulsar. Once you know how it works, you actually can leverage the settings of creating a cluster, updating a cluster, and adding a cluster to allowed list, removing it from allowed list, and updating the replication list to create whatever geo-replication top logic you want to build. So you can build out a aggregation pattern, you can build out a kind of failover pattern, or any geo-replication patterns that applies to your business. So that is the flexibility and the power provided by Pulsar. And as you can see here, it only introduced a kind of an overhead for you is for you to configuring the tenants in namespace on individual clusters, but that can be automated by using a tool like if you have a telephone provider that you can automate all these tenants and namespace creation through a telephone provider. Uh, 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 we if you can develop a parser operator that and a parser entity operator that is automate all these tenants in namespace creation. And we are also thinking adding this functionality into Parcel Manager so then you can use Parcel Manager to easily building out these geo-replication patterns in a very flexible way. And that is the kind of the secrets and also the power of Parcel Geo-replication. Hope this kind of demo give you a better idea in terms of how to set up geo-replication and how to use geo-replication in your for your business and figure out the right approach for doing geo-replication. And the last thing is Pulsar already provide a lot of documentation. Some of the kind of the topics I share is more coming from real production use case and experience working with customers. But mm, you can use the mechanism to do whatever you can do in Pulsar. It's not just about geolocation. You can also use this mechanism for replicating one cluster to the other cluster, and for any data migration, and also setting up any replication mechanism as you need. Um, you can check out all the my show note, and I also have step-by-step instructions for setting up the geo-replication without a global zookeeper using Docker. And I'm going to publish the demo that I'm using. Uh, uh, I'm doing in this show using Kubernetes. Hope this will give you kind of better information for playing around these concepts. And that is the whole show for the for today's episode. I hope this is useful to everyone. And if you have any questions about setting up geo-replication clusters, or you want to consulting for using postal geo-replication functionality for your business, feel free to reach out to us. We also help people design their geo-replication patterns, and uh, you can talk to us, or follow us on Twitter and subscribe to YouTube channel if you think TGIP is very useful. And that's all for today's show, and I'll see you in the next show. And next week I'll probably talk a bit about all the features enhancement in bug fixes in the 251 release. I believe there's a lot of exciting changes related to security and as well as the schema. So I'll showcase those changes. And hope everyone have a great evening, great night, and have a great weekend and stay safe and healthy. And don't forget there's upcoming webinar from Devin talking about common architecture patterns on Pulsar. Thank you, everyone, and thank you for coming to the episode today. Bye bye. Bye bye.